review your test one. This test review question is already posted. I just share on the announcement, which I put it in the PowerPoint and more. This on my on the SharePoint. This one right here. So if you click this link, you can see all the math 1324 PowerPoint. I think I've also posted this one on the Canvas module. I'm not sure, but anyhow, I just want to share this link again, just in case you don't find this one right here, the study guide, which is someone said there's no chapter 1 study guide, so I just posted this one again. I actually organized this one from the book. Okay, so I kind of summarize this one for you, basically. All right, this is how you're supposed to do that on your own when you study the question, right? The chapter. But I just go ahead and summarize, put it in a summarize. This is some of them, most of them from the book, right? So how do you write down? Some people are still struggling. How do you write down the interval notation, right? So if you have, excuse me. You either use the bracket or parenthesis, right? And if you don't have an equal sign, you use the parenthesis. If you have an equal sign, like x less than or equal to 5, so on 5, you will need to use a bracket, okay? So that is the quick and easy one in here. If you have a x is greater than 10, that means 10 is the minimum number, right? And what is the maximum number? So basically, the interval notation, you always write down a smaller number on the left, large number on the right, okay? All right, so there's no ending on the right, on the maximum one. So this is 10 to infinity. And remember, infinity, you always use the parenthesis. You never ever use the equal sign for the infinity, because you never going to, a number never going to be equal to infinity. You can only approach to infinity, okay? So either positive or negative infinity. Positive infinity is always the largest one, so it's on the right-hand side. If you have a negative infinity, it's always the smallest one, so it's always on the left-hand side, okay? So do not mismatch these two. If you have an x less than or equal to 9, right? 9 is the maximum number, okay? You can also drop a number 9 if you want to indicate this relationship, okay? So if I drop a number 9 in here, the first one, x is between 2 to 5, right? So that is 2 in here, 5 in here, right? So this in this interval, that is the x value. The second one, x is greater than 10, right? So 10 is the minimum, and then you're using a parenthesis because there's no equal sign, right? So this will be 10 to the infinity, okay? And then the last one, x is less than or equal to 9. So 9 is the maximum. 9 is the maximum, right? And then this, we are going all the way to the left. So that's why you have a negative infinity to 9. Okay, and then this one is 10 to infinity. All right, so if you understand these three different situations, that's all the expression you have for the interval notation, okay? And then also be able to explain in a number line in here. So it's very straightforward, right? So I usually tell people, say, this bracket is kind of like an equal sign, right? So if you have a x greater than or equal to 1, less than 2, right? So 1 need to have a bracket in here. 2 doesn't have an equal sign, so you use the parenthesis, okay? So always a smaller number on the left, smaller number on the left, right? Large number on the right, okay? So that's the interval notation. All right, so for the slope of the line, the slope is always equal to the change of the y over the change of the x, right? So that's the slope. So the slope is equal to the, we sometimes call delta y over delta x. So delta is the change of the y. So change of y using y2 minus y1. The change of the x using x2 minus x1. Sometimes this, some of them is called y overrun, that kind of thing. All right. So you have a two format for the linear. One is called a slope intercept format, right? Y equal to mx plus b. Another one is the standard form using ax plus by equal to c, right? So that's basically those two major things in here. All right. So that is, so basically this is the formula you need to remember. This is y equal to mx plus b, another formula you need to remember, right? You can change this one to this one or from this one to this one, vice versa, easily, okay? So that is the fourth chapter. Let's see, look at what is the next, chapter 2, which is a little bit more like combine everything, right? So first, you have a quadratic equation. You will, this is the formula. Okay, so some people say, can I have a formula on this one? Okay, so that is the one in here. You can have this page of the formula for the test. Okay, so all right, so if you go to this cell drive in here, formula math 1324, and then this, I also organize this page for next chapter, finance. Okay, so for finance, you can use the finance, finance got a lot of more formulas, so you can have this whole page of the formula. You can print it out, okay? You can print this one out, and for the finance formula. All right, for the chapter 1 and 2, this is the page formula you can use, okay? So you can see this one right here. You have a slope formula, you have a slope intercept formula. This one is called a slope point formula. Okay, if you know one point, you can use y minus y1 equal to m times x minus x1. This one is similar to this one, but a little bit easier, in my opinion. Okay, in calculus, I always just tell people using this one. But if you want to always stick with this one, that's fine. Okay. This one you have to find a b first. Okay, and then plug back to the this formula. For this one, you just need to plug x1, y1. You can find directly, and then simplify. You will get this form. Okay. All right, so this formula, this is the vertex formula. Okay, our vertex, you can, for the quadratic equation, if you want to find a vertex, you can write down in a vertex form, or you can use the formula to find this one. Okay, so that is this one. You can also have a changing base formula in here. Log A of log B of A, you can change it. This is common base. Or the natural base. All right. So you have a log base 10, right? Log A of A over log B of B, or you can change it into the natural log in here. They both are the same. Okay. So you can have this page of the formula to do the test. All right. Since you're gonna use the lockdown browser, so you have to print it out on the paper in order to use. Otherwise, you won't let you open, open another browser. All right. So this one is a little bit, if you have this is called the vertex form, right? If you have this standard vertex form, like so what is the standard vertex form for the quadratic? Okay, so chapter 2, quadratic. If you have a f of x equal to a times x minus h squared plus k, this is called a vertex form, right? So the vertex here will be just h and k, right? So look at this one right here. If I have a f of x equal to -3, This one is negative 3 minus 1 square plus 2. I can compare this one. My A here is negative 3, right? And my H here is 1. My K here is 2. So that means this is the parabola, okay, facing down because the A is negative, so it's facing down. And then the H here, this is facing down, and this is a vertex, so it's something like that. All right, it will be something like that. Okay, so this is already giving you the vertex. All right, so let's call the vertex form in here. Okay, and if you do not know how to convert this one into this one, I can show you very quick. So if I have a f of x, this one I want to take the negative 3 out. Okay, and then negative 3 out, so this will be x squared. 6x divided by negative 3, you're gonna have a minus 2x. And then minus 1. I'm not going to take 1. I'm not going to touch 1 in here. All right. So I just using the x squared and x. And then this one, since you take the negative 3 in, so look at it. If you multiply this in, you're supposed to get this one back, right? So negative 3x squared plus 6x minus 1. These are equal. All right. And the reason we want to take this one out because I want to complete a perfect square. Okay, I want to complete a perfect square. So I want to, inside here, I'll complete a perfect square, right? So how much I need to add, how much I need to minus in order to get a perfect square. This is called adding a 0. So adding a 0, that means did not change the value, okay? So now I have a coefficient of x squared is 1, and then I can complete a perfect square. So the number you want to add here is half of coefficient, half of the b over 2, and then square, okay? So negative 2 over 2 and then square. So this one would be negative 1 square. So you can just add 1 square or minus 1 square. So that's called consider adding the 1, the 0. All right, so now this 3 will become a perfect square. This will be x minus 1 square, okay? This one you have to minus 1 in here. All right. And then we get rid of this bracket. So we have negative 3 times x minus square. This 3 distributed in, right? So negative 3 times negative 1, you have a plus 3 minus 1. And then these two are the like term. Okay, you add that together, so that is 2. So that's how you get to that's how you get to this formula in here. Okay, get to this formula. And you can find a vertex. You can find a vertex that is 1 and 2 for this format. All right, so we do giving you the formula that if you don't want to go through this whole process, right? So how do you find a vertex? Well, I can find a vertex using my vertex formula in here. All right, so that is my vertex formula. So if you have this vertex is equal to f of x is 3 ax squared plus bx plus c, this is your vertex. So how do I use this one to find my vertex very quick? All right. So second way find a vertex. Okay, this time I want to using this vertex formula. All right, so my vertex, it just disappeared. I had to rewrite. Okay, so the vertex formula is negative b over 2a. All right, and my writing pad behave a little bit unusual. All right, let me go ahead and write down in here. Oh, I just using this one. Okay, so I have a negative b over 2a, f of negative b over 2a, right? So basically, I found a vertex x, negative b over 2a, and then I just plug x back to the equation, all right? So my original one right here, right? So my original one, I don't have to do anything. My original one here is f of x is negative 3x squared plus 6x minus 1. I think that's the original one, right? Double check. Yeah, negative 3x squared plus 6x minus 1. All right, so the good thing is if we're using this formula, you don't have to complete the square, right? So my A here, my A here is negative 3. My B here is 6. So negative B is 6. This negative is from the formula, okay? And then 2A is negative 3, right? So negative become positive. So that is 1. So look at that. This is my vertex here. My vertex here. This is 1, right? And then this is 2. Okay. All right. And then how do I find my vertex y? Vertex y, since you have a negative b over 2a is equal to 1. So just using this 1, plug it into the original function, right? So I have a negative 3, x is 1 plus 6 times 1 minus 1. So this is negative 3 plus 6 minus 1. That is equal to 2. Okay, so you can get a vertex is 1 and 2 using this way. All right. So that way you don't have to complete this perfect square, basically. Okay, so you have 2 ways to find a vertex. Any questions? All right, so that is this one right here, okay? And then you have a vertical asymptote, horizontal asymptote. This is applied to the rational function, right? So what's the rational function? Rational function is p of x divided by q of x, right? So you have a numerator and denominator, both are polynomial, okay? And then this kind of function usually is not one piece. Usually it will separated by the vertical asymptote because the graph will never pass the vertical asymptote. It's an undefined point, okay? All right, so if you want to find a vertical asymptote, you will have to find the denominator equal to 0 given that they don't have a common factor, okay? And vertical horizontal asymptote, you just using A over B. All right. So what is the A and B? A and B is the leading coefficient with the same degree. All right. That kind of thing. So you will need to go through all this detail, right? So that is one part of this chapter. Another part of this chapter here is the exponential and logarithm, right? And then you also have to understand this basic exponential rule, right? And then if you have a of x times a of the y, you have a same base multiply, you add the exponent, right? If it's a division, you subtract the exponent, that kind of thing. All right. If you have a to the x to the y power, this is exponent, you multiply the exponent. Okay. So those are the basic one you will need to know. If you have a two equation in here with the same base, exponent must be equal. All right, in order for this to be equal. Okay, and then you also have a compound interesting formula for this one. The compound interesting, you using A equal to P times 1 plus R over M to the MT. All right, M is how many times you compound in a year. Okay. And then you have a continuous compound interest in here. I'm sure this formula, all these two formula are in the formula sheet, okay? And then you also have a logarithm formula. Unfortunately, this logarithm formula is not in the formula sheet, but I was giving this course is so fast, so short. I will let you add this formula on your own to the formula sheet. Okay, you will have that page of the formula printed out, and you can add these 4 formula on the side. All right, this is called a product rule. Okay, so the reason is product rule because it's multiply. Okay, this is not equal to log b of n plus n. If you change 2 log into 1 log, you have to change the operator. All right. So this operator is addition, become 1 log, it become multiply. Okay. And this one is called a quotient rule because you change the 2 log into 1 log. This is subtraction. You have to change it into division. Okay. So you have to change the operator here. This one is called the power rule. If you have a power in here, you can move this power to the front, become the coefficient. All right. And then this is another way to solve the log. If you log b of m equal to log b of n, right? M and n must be equal in order for these 2 log to be equal. And this one, in order for this one to be true, each side can only have 1 log. Okay, if you have a right-hand side got 2 log, you have to, using this property, combine into 1 log before you can write down m and n equal. All right, so now we're giving you a quick review for this section, chapter 2 in here. Like I said earlier, the chapter 2, which is combining quite a bit of the topic in here. All right. Okay, so now we're gonna go ahead and giving you the real review in here. Okay, so this will similar to your test question, but it won't be exactly the same number, of course, or same order. Okay, but will be similar. All right, so let's go ahead giving you the first one right here. If I have a f of x equal to x squared minus 6, right? How much is f of the a plus f of h? So basically, this one you have to separate into 2 parts in order to do this one, right? So you have to find the f of a first, and then you find the f of h, and then you go to add them together. All right? Let me see if I get this. Video. Okay, I was looking for the previous recording, but let's go ahead and talk about it. Couldn't find it. All right, so let's see how do you find the f of a, right? So giving the first one right here, we have a f of x equal to x squared. What? Let me close some of this right here because too many tab in here. Okay, so x squared minus 6, right? So we need to find the f of a. So f of a, you just replace x by a. All right, and then minus 6. So a squared is 64, right? Minus 6, 64 minus 6, I think this is 58, right? And then the second one, you need to find the f of h. So f of h, you just, this is replace whatever x can be changed, right? So x can be changed to a, x can be changed to h. So this will be h squared minus 6. Okay, so f of a plus f of h. We are f of a, we already calculated is 58, right? And then plus f of h. This one you will need to use the parentheses. The good thing is because this is addition, so it didn't change anything. If this is minus, make sure you need to distribute to the parentheses. All right. So this is 50a plus h squared minus 6. Combine the like term always, right? And then 50a minus 6 is 52. So that will be your final answer in here. Okay? Any questions? If you have any question, you can ask right away, okay, before you accumulate too many. All right, second one right here, you want to write down the equation for the graph using A either +1 or -1. And you should know by studying this chapter, right, when this is facing down, coefficient is negative. I usually tell people, say, you can connect with positive and negative feeling, right? So if you have a smiley face, that is positive, okay? If someone has an angry face, right? So that's negative, right? So this one right here, if you have A is positive, A is greater than 0, positive, this is facing up, okay? If you have A is negative, this parabola is facing down, all right? So just like someone is happy, someone is angry, that kind of thing, all right? So easy to connect, right? And this one looks like an angry face, so it's negative. All right, so A is negative in here. So this A will be negative. And then you can enlarge the question, enlarge the graphing to read the vertex, right? So this one you need to go to, so A is negative. We already look at the picture, the impression in here. And then go to find the H. So H is the vertex for X. So you can enlarge this one right here, make it really big, okay? Until you can clearly find out the vertex. So this one right here, look at it. This one is 5. So this is 0. So now each grid is 1, right? So this is to the left. So this will be -1, -2, 0. So this will be -2, right? And then this grid 1, 2, 3, 4, 5, 6. Okay, so this like a 6. So this will be -2 for the x, and then you couldn't see that you can make it even bigger. All right, so 1, 2, -2, 3, 4. All right, so this is -2, right? The in the integer here, -2, and then this one is 1, 2, 3, 4, 5, 6. Okay, -2 and 6. All right, so now we know the vertex here is H here is -2, K here is 6, right? And then we know A is -1. So we're gonna write down this one. So you need to write down the equation. Look at it. This instruction here is that you need to type an equation. So what does an equation mean? That means you need to write down y equal to, right? This one is y equal to. You don't want to write down the p or q equal to. You need to match the original one. So write down the equation. So you need to write down y equal to, right? Y will equal to negative. We don't have to write down 1 in here. We just need to have a negative. X minus h. Okay, h is -2. So minus -2 is +2 squared. And then plus k. K here is +6. So that is the equation you're supposed to write. If you write down x minus -2 squared plus 6, literally this is also correct if I graph manually, but you always need to simplify, okay? Simplify the final answer. So negative, you need to write down positive. So this is supposed to be the simplified final answer, not writing this middle part, okay? So you have to simplify, always simplify. What does simplify mean? Just like a 2/4, you have to simplify into 1/2, okay? So 1/2 is the correct answer. Even if you have a 2/4, it's also equal to 1/2, but you must simplify, okay? This kind of thing, because 3/6 or 4/8, these are all equal to 1/2, right? So if you want to be a computer programming, that's literally impossible to program so many possible answers equal to 1/2. All right, so that's why you always require to simplify. Okay, any questions? So you need to type an equation, and if you only type a if you only type a negative x plus square, even this one is you got a correct answer. But if you don't type an equation here, the minor math will still count you wrong. Okay, so you always have to read the instruction very carefully. Okay. The good news is since the test you only have one try, so I will always check everyone's test after you submit. Okay, so I check everyone's test. If you have this kind of simple mistake, I usually giving you the partial credit. Depends on how much you got it correct. All right. If this you only forgot the equal sign in here, if this is 6 point, you might get a point off. Okay, you still won't get the total score, but at least you will get a 5 point for that. All right, if everything is right, you just forgot an equal sign. All right, but I do not want to check you with the homework because the homework is a practice. You have to practice until you get it right. Okay, but since the test is only, I don't want to check you the quiz as well because the quiz you have a multiple 3 tries. Okay, so the only thing I will check give you the partial credit is the test. Okay, because test you only have a 1 try. Questions? All right, number 3. This one, how do you find a b without using a calculator? All right, this is called a logarithm. You need to transform into exponential equation in order to make it work. Okay, so if you have a log b of x equal to y, giving you a general one right here, right? How do you change this one into exponential? I usually tell people, say, drop a circle, right? This one is b, the base. B is called a base, okay? Base stays the same. What does that mean? That means the base in a log is also the base in an exponential equation. So this b, when I'm raising the power of y, will equal to x. Not b to the x equal to y, okay? If you get rid of the log, you have to make a circle, kind of make a drop a circle, start with the base, all right? The base b raised the power of y equal to x. So now we come back to solve this one right here. Okay, so now it should be easy. So this is base b raised to the power, base b raised to the power of -4. We are equal to 625. Okay, so how much is the b? Well, I will have to change this one into called a same base. Okay, so I'm gonna have to raise to the power of -4. If I can write down this is something to the power of -4, right? Write down the something to the power of negative. Remember, if I have a b to the x equal to b to the y, my x and y must be equal. Okay, so if I will change this one, so in this case, is the power, the exponent is equal, your base must be equal. All right, if I say this is a raised to the negative power will equal to b raised to the negative. B and a should be equal, right? This is kind of like the logic, the math logic, right? In order to be equal. So the button here is how do I change this one into the -4 power? Well, you can, the quick and easy one here is you can go to put it in a calculator, okay? Just change 625 to the -4 power to see how much is come out. I'm sure you'll come out something, right? But we know 625 can always be divided by 5. If you have a last digit is 0 and 5, they can always be divided by 5. Okay, so if you have a 625 divided by 5, That's 1, 2, 5, right? And then this is still ending as a 5, so you can divide by 5, 25. And then 25, of course, is 5 squared. So 625 actually is 5 to the 4 power. All right, 5 to the 4 power in here. Okay, and 625 is equal to 5 to the 4 power. And then if I put a negative on both sides, right? If I want a negative on both sides in here, that means this will be, you can write down 5 to the negative 1 power. So this is 1 over 5, 1 over 5 to the negative 4 power. Okay, all right, so now I have a b to the negative 4 equal to 1 over 5 to the negative 4 power. So b must be 1 over 5. Because in order for these two to be equal, the power is equal, the base must be equal. Just like this one is the base is equal, the exponent must be equal. Now you have an exponent is equal, base must be equal in order for this to be equal, right? And this is do that manually. As I mentioned earlier, you can put this one in the calculator. Okay. You can put this 625 to the negative 4 power, right? And then let me show you the calculator. It will come up really quick that way. Okay, so we have a 625 to the negative 4 power. Okay. Oh, hold on. Let's see, what do we get? Oh, I'm sorry. No, this is not 625 to the negative 4 power. It's a number, okay? A number need to raise to the negative 4 power. A number need to raise to the negative 4 power equal to 625. Okay, not 625 to the negative 4 power. I take it back. All right. Okay. So if you want to do this one right here, right, you want to find this unknown base, okay, this unknown base in here, all right, you will need to take the all right, you will need to take the 4 power basically, all right, 625, 625. If you take the fourth root, okay, so let's clear this one right here. 625, if you take this one is to the fourth root, divided by 1 over 4, fourth root. This will giving you 5, right? That way. So that means 5 to the 4 power, as I mentioned earlier, 5 to the 4 power is equal to 625. Or 625 to the 1 over 4 power will equal to 5. Okay. But I want a negative power. So what is a negative power? Negative power, that means if I have a to the negative 1 power is equal to 1 over a, right? So 5 to the negative 1 power is equal to 1 over 5. Okay. So yeah, if I have a 1 over 5, what is 1 over 5 to the negative 4 power? If you look at the 1 over 5, 1 over 5 to the negative 4 power. All right, so that is equal to 625, right? Because 1 over 5 to the negative 1 power is giving you 5, and 5 to the 4 is 625, okay? So that is B is equal to 1 over 5 in this case. All right. Okay, so this one is telling you don't use the calculator because you have to change this into you will need to change this one into exponential equation first in order to find the b. Okay. Any question about this one? All right, I would rather to use this one as a discussion than me just talking. Okay, if you have any question or you have any better way, don't go ahead and don't hesitate to jump in. Okay. All right, find the slope and the y-intercept in here. So if you look at this one right here, this is on chapter 1, right? So this slope and y-intercept, this is already in the slope point, slope and intercept format. So what's the slope and intercept format? We just reviewed earlier. If I have a y equal to mx plus b, my m is the slope and my b is the y-intercept, right? So this is negative 5 over 7x minus what? Minus 6, right? So that means my m here is negative 5 over 7, not 5 over 7, don't include x, okay? Don't include x in here. This is a slope. Slope is just a number in here, all right? It's negative 7 over 5, okay? And look at that. It's a type of an integer or a simplified fraction. So that means if this fraction you can be simplified, you have to simplify, right? Y-intercept. So how much is y-intercept? It didn't ask you to write down in the order pair. Instead, you just type an integer. So the integer for the y here is negative 6. All right, so y here, the y-intercept here, so you just type a negative 6 for the y. This slope, you don't have to write down m because you don't have to write down the equation for this one. You just type an integer. So the slope here will be just negative 7 over 5. Okay, so that's your slope. All right, so now after the chapter 2, you come back to the chapter 1. It sounds much easier. Okay, complete a square and find a vertex for this quadratic equation. You can complete a square or you can just using the slope form. I'm sorry, using the vertex formula. All right, so what is the vertex formula? This one you want to complete a square. So how do you complete a square in here? All right, this one is a little bit easier because my x squared coefficient is already 1. So if this one is already 1, you just look at the middle term. You will need to add and subtract some kind of number. So we call this one is adding a 0. So when you're adding a 0, this equation is still equal to the previous one, right? And how much you have to add in order for this 3 to be a perfect square, for this 3 to be a perfect square. Okay, so if you have a plus b perfect square, if you remember this formula, that will be really easy, right? So if you break down this one into expand this perfect square, you need to have 3 terms. So you have a squared plus 2ab plus b squared. Right now, I want to these 3 become the perfect square. So basically, you have this term and a second term. You want to add a third term. So that's why the third term you have to square something, right? And this square is a half coefficient of this. So using 10 divided by 2, which is 5. So you need to add a 5 square, but you also have to minus 5 square in here. So that will equal. Okay, so this 3 here will become a perfect square, x minus 5 perfect square, right? And then you go to minus this one, 5 square will be 25 plus 95. These two, you combine them together. All right, so that will be 70. Yeah. All right. So that is you perfect square in here. And your vertex here, compare the vertex f of x is a times HK, right? So your A here is 1. Your A here is positive 1, positive 1. So this one will be facing up, right? Positive. All right, and your vertex here will be 5 and 70. Okay, 5 and 70 for this one. All right. So this one, you just want to complete this perfect square in here. Okay, this number 6 is you cannot really using the calculator. You just have to know the character for this whole thing, right? If you have a y equal to f of x, is showing in red. Okay, so the red one is the original one, y equal to f of x. And you want to graph the y equal to negative f of x. So what does this one mean in here? That means the x did not change, but y become negative. Okay, so that means everything is opposite. So basically, this graph is reflecting across the x-axis. All right. And then you can see this one reflection or symmetry around the x-axis in here. So that's the character. So now you can go to really see which one is a symmetry to the x-axis, right? Apparently A and B doesn't look alike, okay? So the possible correct answer would be either C or D, just for eye browsing, right? But we need to analyze a little bit more detail in here, okay? So does A or B, C or D, which one is the correct one, okay? So we can do a little bit of hue point in here. If you look at the C, the red one is original one, right? So the red one in this point here, this point is y is negative something negative 1. My blue one, since this is negative, my reflection symmetric with the x-axis, so this should be positive one, so it should be right here. But this one, they have a same y in here. This one you have a same y, and it's not 0. And this one, so this one apparently is wrong. Okay, let's look at this one right here. You have a negative 1, negative 2 in here. This one is positive 2, so that's correct. 0, y is 0, so that is right. So the correct answer should be D, right? So this one should be really easy to identify. Okay, so we have a correct answer as D in this case, okay? All right, so number 7, you want to write down the equation for this polynomial. So this polynomial looks like a quadratic, right? You recognize this graph is quadratic. This graph is also a quadratic, basically. All right, so this one is facing up. So facing up is positive. So the coefficient, the leading term coefficient should be positive. A is positive in here. And then we just need to write down go to do this vertex, right? Ooh, now where did it go? All right, so write down the vertex in here, right? So we have this vertex in here, looks like we have an x in here, right? And then this one is 5, right? So this looks like a okay, so write down the equation, okay. This one I might want to using quadratic equation f of x equal to ax squared plus bx plus c. That's the standard format for the quadratic equation. And then it said the leading term using positive or negative. So this one, A is positive one because it's facing up. So I can just write down my f of x equal to x squared plus bx plus c because A is already 1. Okay. And this vertex don't look like a integer, okay, because I do not see this vertex as an integer in here. This y vertex for the y is not an integer because it looks like a 6 plus something. So I cannot really using the vertex because the vertex is not exactly the integer. But I can using the x-intercept and the y-intercept. Looks like this one has a y-intercept right here. Y-intercept looks like an integer. The x-intercept is also looks like an integer in here. Look at that. So this one will be 1, 2, 3. One is positive 3. The other one is negative 2. Okay. So positive 3. So we have an x-intercept. We have an x-intercept here is 3 and 0. And then this one here, this point right here, this point here is negative 2 and 0. All right, so we got 2 points. We don't really need a third point to find that one. So we got 2 points in here. We can find a B and C, right? Or if I want to find an easy one, I can using this point, the y-intercept. The y-intercept looks like this one is 1, 2, 3, 4, 5, 6. So x is 0, y looks like a 6. So you have a y-intercept 0 and negative 6, right? If I use this one, even easier. Okay, so if I use this one right here, y is 0. I'm sorry, x is 0. X is 0. So 0 square plus 0 b plus c. Y is negative 6. So this is 0. This is 0. So I can find my c is negative 6 right away. So c is already 1, right? And then you just need to find a b. Okay, so f of x equal to x squared. B is negative, c is negative 6 in here. So I'm just using this point to find a b. Okay, so y is 0, x is 3. 3 squared plus 3b minus 6. So that's 9 plus 3b minus 6. 9 minus 6 is 3. Okay, and then a minus 3 on both sides. Okay, divided by 3, so b is negative 1. All right, so I have my f of x equal to x squared minus b is negative 1, so minus x. C is negative 6. Okay, so I don't have to use this one, but this one, if you plug this one in, is also correct. Okay, look at that, 0 equal to negative 2 squared minus 2, 6. That's 4 plus 2 minus 6. That's equal to 0, right? So that is correct one. Okay, so this one you have to be very careful. Don't use a vertex because this vertex is not exact integer. So you will need to find a using x-intercept or the y-intercept here to find your ABC. And then it already telling you leading term coefficient A will be positive or negative one. So you don't have to find an A. All right, in this case. Okay, any question about this one? All right, this one you just have to know how does this kind of base function look like, right? So if you have this kind of base function, I mean, you can plug it into the calculator to graph each one of them, but you also need to know the base function in here, okay? Some of them, especially if you want to go to the next math, so n of x equal to square root. How does the square root of x look like? This is how square root of x look like. Okay, or you can put in a calculator. And how do you graph the absolute value? Well, absolute value is like a b. Okay, like a b. So that's g of x equal to absolute value of x, right? And then the cubic function. So what is the cubic? What is cubic look like? Cubic is going to the like this one. So that's x cubed, right? And then you know the x squared, okay, this vertex will be just on the origin. So that's y equal to x squared. Okay. And then identity function, so that one is linear, right? So that's linear. That's the straight line, y equal to x, right? And then y equal to cubic of x. F is cubic. Cubic is a little bit slower, but that's something like that. So y equal to cubic of x. Cubic root Q loop of x in here, right? So you can see this one right here. This will be the D of quadratic equation. Okay, so that should be the multiple choice, or the graph. All right, and if you don't know, some people asking how do I graph the absolute value, right? you can go to this one right here. You can go to the math, okay, and then go to the number. The first one is the absolute value of the x, okay? That's how you can find the absolute value of the x in here. Or you can graph y equal to x cubed, right? So this is x to the third power is the x cubed, okay? So that's how x cubed look like. Or you can have a Q loop, okay? What is the Q loop? If you go to math here, you can find a Q loop in here, okay? So that's the Q loop graph, all right? Or if you calculator don't have this one right here, Q loop is x to the 1/3 power, right? It's similar. Q loop is 1/3 power, so this will graph the same graphing as the Q loop, that one. Okay, so those are the graphing we are kind of familiar with that. Okay, I think this one solve for this equation in here. This remind you e to the negative x never go to 0. Okay, so I can show you why this one never go to 0. Okay, this is a exponential equation e to the negative x. All right, so second ln is the e, right? E to the negative x. All right, so that is the graphing in here. It looks like a 0, but this one is not 0. Okay, it's very, very close to y-axis because if you go to the table right here, look at that, it never go to 0, right? Look at it. This one is going really big. This one is going really, really small, but never go to 0. All right, so you have to know this character for the exponential equation. Okay. All right, so since e to the x never go to 0, the other one must be 0, right? Okay, we can factor, we can take this e to the x out, e to the negative x out. So this will be just x plus 7 equal to 0. Remember, if I have a times b equal to 0, one of these should be 0, okay? If none of this is 0, you multiply won't be 0, all right? This one is telling you e to the negative x never go to 0. So if this one never go to 0, the only thing can be 0 is just x plus 7 equal to 0. So you don't have to solve this one. The only answer here, x will be negative 7. That's the only answer. Okay. This one is using the comment to separate answers as needed, but I don't have a more than one answer, so I don't need a comment in here. Okay, I just have a x equal to negative 7. This is only one answer, right? Because telling you, remind you, this one is never go to 0, so you don't have to solve that one. All right, number 10, you want to write down this one in an equivalent logarithm form, okay? As I mentioned earlier, you will transform like a log b of x equal to y, right? Transform vice versa. So base stay the same, drop a circle. So this one will be b raised to the power of y equal to x. Okay, so now I have a 125 equal to 5 cubed, right? Or you can write down 5 cubed equal to 125, right? And then the base stay the same. So this is a base. This 5 gonna be the base. Base raised to the power of 3 equal to 125. So that's how you write. Okay, that's how you convert. After you convert, you can write down this one back, write down in an exponential to see if you can get the same answer. All right. Okay, number 11 is about solving the compound inequality, and this one is your chapter 1 question, right? And then graphing. So how do you solve x in here? Okay, this should be not too much trouble. Okay, so I usually tell people, say, go ahead, solve as it is, right? Don't try to separate this one because you have to put it back if you're trying to write down the interval. So the solution set of the inequality is what? Now you read the question right here. Simplify your answer using the integer or fraction for any numbers in the expression. Type your answer in interval notation. So your final answer must be in the interval notation for this one. If you don't, it will counter you wrong. Okay. Although I will check if that's the test. All right, so we want to answer the x. So first we get rid of this a. So we add all the a, all of them, right? So this will cancel out. So 5x will be less than, greater than, or equal to 2 plus a is 10. 32 plus a is 40. We divide by all of them by 5. Okay, since 5 is positive, so you don't change any inequality direction. All right, so 40 is 2, right? All right, so you choose the correct answer, okay? So 2 and a. 2 is bracket, a is the parenthesis, okay? And then if you got this one will be 2 is bracket, a is parenthesis. That's your interval notation, okay? So this is your final answer. You have to write down in the interval notation and then go to match your correct answer in here, right? So 2 is the bracket, a is the parenthesis, okay? Any questions? Once you figure out the interval notation, it should be easy, right? And then this one is just a regular equation solve for x. So that should be really easy. Get rid of your parentheses and then solve for x. Okay, so 3x, right? Minus 3 times 2 is 6 plus 7, 2x plus 6. All right, so these two are the like term, right? Combine them together. All right, I can minus 2x on both sides. Okay, so this cancel out. So x, 3x minus x, this will be just x, right? And then you minus 1. All right, so that cancel out. So x will be just equal to 5. You only have one answer, so you don't need to comment anything. All right, final question for any horizontal asymptote and answer all these questions, right? First, if I want to find a horizontal asymptote first, does this one has a vertical asymptote? The answer will be yes. This is called consider a rational function. Okay, so rational function, that means you're gonna have a different pieces. Okay, so this rational function here, f of x. My numerator, I cannot simplify my numerator. Okay, my numerator is a prime. Okay, so there's no common factor, so I cannot simplify so vertical asymptote is when denominator equal to 0. So x minus 14 equal to 0, x will be equal to 14, right? So that's my vertical asymptote. Do I have a horizontal asymptote? The answer is no. I don't have a horizontal asymptote. Why not? Because this numerator degree is higher than the denominator. So if I go to adding if I go to match a same degree, right? This is x squared. So if I add a 0x squared, my horizontal asymptote is supposed to be the same degree. When I have a same degree, you're using the coefficient divided by the leading term. So this will be 1 over 0. 1 over 0 is undefined. So that means that we don't have a horizontal asymptote. Okay, if I flip this over, that one we will have a horizontal asymptote, right? So this one, the answer here is this one doesn't have a horizontal asymptote. Okay, if you put this one in a calculator, let's see how you look at that for this one. Okay, so you do need to use the parentheses because this one has more than one item. Okay, let's see how this polynomial look like. This should have more than one piece. So let me go ahead and zoom fit. Oof. Okay, we're gonna reset this one right here. Why I didn't see the other piece should have a two piece, probably one piece somewhere right here. Okay, let's increase the positive window. Okay, so this one does have a vertical asymptote is um, has a vertical asymptote x equal to 14, but the vertical asymptote is not part of the graph, so usually they don't graph it. They don't graph that, right? You can see like when x equal to 14, y is an error. So what's the error? That means y doesn't exist. Okay, so that is the vertical asymptote in here, because that is the graph will never pass x equal to 14, this one. Okay, so that's a vertical asymptote. So this one doesn't have a horizontal, all right? But if I have a, if let me give you one of them has a, if like I said, this is 13b, right? So I have a g of x equal to like I say, 3x squared minus x plus 1 over x squared minus 2. Now I do have a horizontal asymptote, okay? So this horizontal asymptote will be just, this is the same degree, x squared, right? So this will be 3 over 1, or just equal to 3. So y equal to 3 is the horizontal asymptote, okay? So that's why you have using the same coefficient and using the coefficient of the same degree term, the leading term. Any question about this one? All right, what is the maximum number of the x-intercept polynomial of the degree 6 half? Well, the degree of the 6, the maximum asymptote, the maximum number of the polynomial, okay, degree of the 6, the maximum number of the x-intercept is 6, okay? So why is that? Look at that, the quadratic, right? Quadratic, this is quadratic, you can have a 2 x-intercept, okay, the maximum. You can have just one x-intercept. Okay, like this one is still quadratic. Or you can have a 0 if we're facing down, and in here, this has a 0 x-intercept, right? So the maximum you can have is 2. It's the same as the degree, the number of the degree, right? This one right here, okay? All right, last question here is indicate, is this a function or not? Okay, so this is a domain. Domain is also called input, right? Or sometimes we call it x value. The range is called y value or the output. Okay, so this one, in order to be a function, one x must only have one y. So this one domain has a two output, two range in here. So therefore, this one is not a function. Okay, in order to be a function, you have a one input. In order to be a function, okay, one x can only have a one y. They can have a same y, like a 3 corresponding to 5, 2 corresponding to 5. This actually is a function. okay? Even they corresponding to the same one. But look at it, because this is X, this is Y, right? One X, I only have a one Y. One X, I only have a one Y. Even they have a same Y is okay, but it only have a same Y. It only have a one Y, even they are the same. But this one domain has a two Y, two outputs, so therefore it's not a function, okay? All right, so I just going through the quick review for all these test questions. So yeah, you chapter 1 and chapter 2 test is around 15 questions. Okay, so not too many. You might have to do more homework than the test question, that's for sure. But the test question usually, if you can finish all the homework without big challenging, your test should be all right. Okay. All right, any questions? So we just went through the whole chapter test review. So the test 1 will include chapter 1 and chapter 2. And then you are after the test due on Sunday, you want to move on to your chapter 3, which is the finance. Okay, finance is the big chapter as well. But this is business math, right? So the finance should be an interesting part. Okay, and then we're gonna come back next week, next Friday, to review the chapter 3, and I will also try to use the calculator to find the annuity or the mortgage payment for the chapter 3. Okay, so that should be a real life application for the finance, right? We always say like I don't know how you K to 12, but right now the federal government trying to kind of, I don't know if it's mandate or recommend, but they definitely strongly recommend to have a financial literacy in K to 12, right? So people won't get into the too much credit card debt. The credit card debt is a really big business, right? But it is, you come to the community college, so you are in a good choice, nice choice for your education. Yeah, it is, you don't get involved in too much student loan debt, right? That kind of thing. So that's a smart choice that way. Okay. All right. Any other questions? Okay, I am going to stop the recording, but I will stay on the line. I know some people probably need some help. I will go through the one-on-one help or small group help or whatever you have. If you don't feel comfortable to ask the question of the entire class, that's fine. I'll be still online, okay? And then I'm going to start the recording. All right, so you are now being recorded now. Recording is stuck. Okay, any questions? All right, if you don't have a question, you can be offline and then we count the attendance by now, okay? You can still email me if you have any questions.
Hi, Mrs. Abram. How are you?
Good, thank you.
Good. Um, Yesterday I had to go to the tutoring center to kind of help walk me through some of the steps for chapter 1. Um, I'm in barely doing homework 2.1 and 2.2.
So
I
you
was
come a
wondering if
little bit behind, right?
yes, I am. Yes.
Yeah.
I was wondering, sorry if it's a little loud. I was wondering if you can help maybe like walk me through a couple of homework steps on 2.2 and on 2.1 and 2.2?
Yeah. If you don't mind sharing your screen, or that you open your screen, and then we can walk through that way. So at least let me know with the question you have.
So this is the first question on the 2.1 and 2.2.
Okay.
Homework.
All right. So this one, you want to click on this enlarge graph, right? Click on this one before you can put it in here. So you need to.
I'm sorry.
Using the point by point to plug to graph this one. So basically, you have to calculate at least 2 or 3 points. Okay. So
Oh,
before
okay.
you do this one, you have to write down, like say, when x is 0, y will be 0. You have to calculate first before you can put it in here. And when x equal to 1, y will be -5. So you have to calculate a couple points before you can sketch the graph.
Okay. So I think
So
my
if you click this
issue
one,
is.
okay, you go ahead, click this one to see what you have.
Oh, okay. Okay.
Yeah, and then you have to choose it since it's a qubit. So this one should be the qubit. Choose the qubit one.
It'll be this one right here, right?
Yeah. Okay, and then go to the graph. And then you have to, that's why I tell you earlier, you have to know the point. So 0, 0 is the 1 point. All right. And then when x is 1, y will be -5. So yeah, and then y is negative. So 1 and -5. X is 1. Now x is 1.
Oh, x is 1. Sorry.
Yeah. X is 1. Y will be -5.
Okay. And then
And then you have to click that.
and then I have to do what?
Okay. Select 4.
The noise behind me is also not helping because someone's mowing their lawn outside, so
Okay.
I can't hear
Yeah.
very well.
Look at it. You click on this point is 5, and graph the point out of the curve. You have you look at it. You have a 5 and -15. So that's not the right one, right? You have to put a graph a little bit bigger. You can enlarge the graph a little bit bigger in order to
Oh, over here on the X.
okay. So now you have a okay. Now
Oh,
you have
it's
to start
here.
over. Yeah.
Yeah.
You maximize. Let's go ahead. Close that one and make it a little bit bigger. Close the graph. Make it a little bit bigger. Enlarge a little bit bigger. Click this one. No, click this one first. Click this one. Click this the one with this one right here. Yeah. Click that one. Make it really big. Okay, and then you go to the tool. Okay, so that's better. Now you go to the tool, go to the qubit tool. You have to choose a qubit tool. Okay, so 0, 0 is the 1 point. Yeah.
Mm-hmm.
Okay, so that's 1 point. So and then you go to when x is 1, y will be -5. So 1 and -5. No, that's not a 1. Okay, and click. All right.
Yes.
And then when x is -1, y will be +5. -1, y will be +5. And you click one more point.
Okay. So I think for me, it's just I'm trying to figure out like how do I start this? So y
Okay.
equals -5x cubed.
All right.
Where
So
do I get the
before you okay, listen, before you do this one, you have to know 3 things. Fourth thing here is you have to click the right tool, right? You don't click the straight line for the qubit. So you have to know how the qubit look like. So that is the qubit tool. Second, you have to calculate at least 2 or 3 points. In this case, you might need to 3 points before you can graph this one. So how do you graph the 3 points? You pick an easy point in here. When x is 0, you plug this one into calculation. X is 0, y will be 0, right? So that's 1 point. And then calculate another point when x is 1, plug x equal to 1 in. That's -5 times 1 cube. So that's still -5. So you have a 1 and -5. So that's another point because it's a qubit, so you have to find at least 3 points. And then another easy point here is when x is -1. So -1 cube will be still -1, and -1 times -5 will be +5. So now you have a -1 and +5.
Okay, that's this one right here.
So yeah, so you do have to have like 3 points and then using the right tool, and it will graph.
Okay.
Yeah. Now it will graph, and then you can save that.
Hold on 1 second.
Yeah.
Oh, every time I move make it bigger or smaller, it clears.
Yeah, you have to, after that, there's a save button here. Remember, you have to save.
Okay.
You have to save there, and then you have to click those 3 points we just went through earlier.
Okay, so then how do I save it, like that?
Well, that doesn't look right.
Click to
You already changed it. You have to practice that a little bit, and then look at the number you have in here. Look at the number you read in this number in on the yellow line. When you click, you have to read the 0 is the correct one. So you have to read the number and then click there. Okay, and then go to 1 and -5. Okay, so that's the right one. So click there. You have to click there. Yeah.
Yes. Well, so when I move my arrow, the graph moves too. So
all right, let me go to mine. I'll show you one because you just have to click that and save that. All right, let me share my screen instead, and I will go to you. Let me share my screen. Okay, and then I will go to the homework. Hold on, that is 2.1, right?
yes.
Okay, so let me go to the 2.1. I'll just showing you one of the
Yeah, if I can, if you can show me that one, and then there's another one, another problem that I didn't quite understand.
Actually I go to your homework, but you won't do your homework, but I'll show you your homework question that way.
Well, and then a lot of them are very like similar. So, if I can get some notes on how one is done, I'm able to most likely, figure out the rest.
Right. So you still have to calculate. You cannot just not calculate. You won't graph if you don't calculate. Another thing is if you do not know, you can use a calculator graph first before you create.
How do I download that?
You can use your cell phone app. You can purchase a TI-84 app.
Oh, okay.
So -5x cube, right?
Yes.
And then you can have this power 3. Okay, so that's cube, and that's the graph. All right. Let me go ahead, zoom standard. All right, and then you go to the second table. You can see the integer in here. Look at that. You can choose you can choose 0, 0 if you don't want to calculate on you by hand. So you have a 0, -1 and 5, 1 and -5, right? This 3 point will be easy to graph.
Okay.
Yeah. So, but so you do have you do need to calculate the point. Now let me open this one. So I just want to show you that, and then you just copy to the homework.
Yeah, that one makes sense. I can get that one.
Right. Or you can calculate, just plug the number into calculation. That's fun too. But at least you know the graph will look at something like that, right?
Yeah.
All right. So
I've
let
never
me go
had to
to.
use the I've never had to use the
All right.
graph
Let
on
me
here
see.
yet.
What's your last name?
Castillo, Castillo.
Alisa.
I tried to go to the tutoring center today, but they were closed. They closed at 5 and I get off of work at 5.
Okay. So that's 2.1, right?
Yes, 2.1, 2.2. I think it was at the top.
Oh, okay. All right. So let's review this one, and then which one you were talking earlier?
Well, the if you can now help me review question 6, because with the graph, if I can do the graphing with the calculator, that I can understand that.
Okay. All right, so this one is a domain, right? So domain for the even part need to be greater than or equal to 0. Okay, so this domain here, so 3 minus x need to be greater than or equal to 0, and you solve for x.
So the 3 minus x, that's rooted, that is the domain.
Yeah, because
Okay.
this one is a even power, even root, even root need to be
Okay.
positive. And then you add an x on both sides. So that's the easy one.
Okay.
And then so x should be less than or equal to 3.
Oh, okay. So is that kind of like the is it the inter
Now this is not an interval. This one is
oh,
just the inequality. So now you have to write down the interval less than or equal to 3 is going this way. All right.
okay.
So your interval should be in negative infinity to 3.
Oh, okay. Yeah. So that one I understood.
Mm-hmm.
So then okay, so this is considered an even root.
Mm-hmm.
And then so basically we're doing the 3 minus x is greater than or less than 0.
Greater than or equal to 0 have to be positive, or it is positive or 0.
Okay. And if it's negative, then it's less than?
Yeah.
Okay. Okay, and then basically just make sure x is on one side, so then subtract the 3, and then
Well, if you subtract 3, now you have to divide by a negative x. So it will be much easier to just add an x on both sides. One step instead of 2 steps.
you said it's much easier to add an x on both sides?
Yeah,
Okay.
because this is negative x. If I add x on both sides, this cancel out, right? So I have a 3 greater than or equal to x. And then if you write down x on the left, it will be x less than or equal to 3. Because look at it, if you want to minus 3, okay, now you have a negative x greater than or equal to negative 3. Now you have to divide it by negative 1 in order to get a positive x. But if you divide it by a negative number, you have to change the inequality sign.
Okay. Okay. So I see. So it's more steps doing it that way rather than just
Yeah,
okay.
yeah, more step doing this way. Positive, yeah.
Okay.
Or much more step than the other one.
And then so when it means the domain of gx equals whatnot is, so then it's just the x is less than 3.
No, you have to type it in the interval
Oh,
notation.
interval notation. Okay,
Remember,
so
you have
that's
to
the
read
infinity.
yeah, this is your interval. That way, you have to read the question very, very carefully. That's what I said
Yeah.
earlier.
Yes. I have noticed that on the other homework as well.
Yeah, because even you got an answer correct, but if you don't express in the correct format, it will still count you wrong.
Okay.
So that's why I tell
Okay.
people you have to read the question twice before you answer it.
Yes. Yes, I agree. Okay, well, I appreciate your help. I'm gonna definitely head to the tutoring center on Monday. They're closed on Saturday and Sunday. I was just checking that. Do you
Okay,
know?
let me tell you, let me show you one more time for this one. So this one is still a domain, right?
Okay, find the
So this
domain
is
and
also
range of
the square root. Square root is also the even root. Okay. But the even root here, this even root, this one is only square root of x. So everything under the root has to be positive or 0.
Okay.
So this one you don't have to solve because this one is just x. So x will be greater than or equal to 0. But you write down the interval, that's your interval.
Okay, so the bracket 0 with infinity. Okay.
Yeah.
Oh,
So
so then, so the x is always on the left side, right? On
yeah,
the
when you want to write down the interval, you want the x on the left.
okay. And okay, so like for example, where the domain is x is greater than or equal
So
to 0.
domain is everything under the even loop. If it's a R loop,
Okay, that's
it's a
right.
Q
We
loop,
did
you can have anything. Q
you
loop
did say that.
doesn't matter, but it's only the even loop. Even loop, you have to be positive. That's the rule.
Okay, okay. Um Okay, that one I understood. But you know, it's crazy because when you look at it, like you wouldn't think it would be
Yeah,
that easy.
right. Because if you understand the concept, it's much easier.
Yes. Okay. Well, I mean, I appreciate that. That helps a lot. I'm gonna continue to work on this, if not tonight, tomorrow,
Right.
but
And you also can get more help right here. Look at that. You can view an example, you know that.
okay.
Yeah, this view example will be very helpful. Look at that. View example, you explain everything and then continue.
Okay.
Okay. This view example telling you everything in here.
Okay. That I'm gonna use that one,
Yeah.
definitely.
Yeah, you get more help. Go to view example if you don't know that way. And then you can still, textbook, but view example even more helpful. That
Right.
one.
Because it'll
Mhm.
be a very similar problem, just different numbers.
Yeah,
Okay.
right.
Okay, awesome. Well, I appreciate that so much. Thank you for your
Oh, no
help.
problem. Okay. Any other
Okay.
questions?
Yeah, no, I think I'm okay for now.
Yeah, I think that you just need to catch up because it looks
Yeah.
like you're behind that way.
Yes, I know. I
Yeah.
the trip and me being sick, that all of it together didn't
Right, right,
and I'm
right.
not the best at math either, so
Yeah, that's fine. But the summer is just so fast.
short. Yes.
Yeah.
Thank you. I
All right,
appreciate
you're
you so
welcome.
much. Thank
Okay,
you.
no problem.
You have a good evening.
You too. All right.
Bye-bye.
Bye.